Hello everyone, and welcome to this very special episode of World of Sharks, because not only are we celebrating the end of a landmark year for the Save Our Seas Foundation, our 20th anniversary, which we've been celebrating for the whole of 2023, this is also a milestone for the podcast because it's our 50th episode, which I can't quite believe. That's over 2 years and over 50 hours of interviews with some of the brightest minds in shark science, conservation, education, and storytelling. And to be quite honest with you, it doesn't really feel like work. It brings me so much joy to learn about these amazing animals along with you and get to pick the brains of incredible people doing incredible things to help create a better future for sharks and rays. If you are new here, hello, hi. This is the official podcast of the Save Our Seas Foundation, where we talk all about sharks, rays, and the ocean. I'm Isla, your host, and every episode I sit down with an expert to take you on a deep dive into a different part of the wonderful world of sharks. Now, we were trying to think of a suitable topic to mark such a special occasion, and we thought, why not take an opportunity to celebrate sharks themselves? Well, I mean, we do that every episode, but today we are talking about the incredible longevity and success of sharks and their relatives. You know, what are the adaptations that have allowed them to diversify and occupy almost every ecological niche in the marine environment that you can think of? What has allowed them to rise to the top of the food chain or become keystone species? And just how much they've survived and overcome in their over 440 million years on this planet. And to help me take a bite out of this quite sizable topic, I have regular podcast guest Dr. James Lee, shark scientist and the amazing CEO of the Save Our Seas Foundation. It's kind of become World of Sharks tradition to have James on the last episode of the year, and it feels particularly fitting to have him on during the Foundation's 20th birthday. And we just happened to be in the same place at the same time, so we just decided to go for it. We had such a laugh recording this, discussing the intricacies of the 5 mass extinctions, shark superpowers, and a slight tangent about Bruce Willis, Die Hard, asteroids, and shark survival. It's quite amazing how we managed to pull those threads together, so make sure you stay tuned for that. But before we dive into today's episode, I just wanted to take the opportunity to say a huge thank you to each and every one of you at home who listen to this podcast, who take the time to write into us or leave us a review or message us on social media. It's one of the biggest joys to make this podcast for you, and I am so thrilled that so many of you are enjoying it. It's been amazing to see this community of shark nerds grow, and it really means a lot to connect with all of you, so thank you. Okay, soppy stuff aside, get ready to go back in time and let's dive into our episode. Well, I mean, welcome to our 50th episode. Cheers.
Cheers. Yeah, 50 episodes. Congratulations. That's pretty much like 50 hours. Well, you've obviously been chatting more around that, but you've got 50 hours.
Yeah, probably more than that. Yeah, 50 hours of shark chat.
It's like a shark chat marathon twice over.
And more to come as well, hopefully. But yeah, we're both in Seattle.
Yes, it's wet and rainy and cloudy. So it's very much like home, but yeah, no, it's cool to be here. And we're actually in person. We have recorded in person before.
Have we?
In Valencia for Sharks International.
Oh yes, because you were on the funding episode.
Yes. Yeah.
Yes. So for listeners who are unfamiliar with James has been on the podcast many times before, and that's because James is the CEO of the Save Our Seas Foundation, and I regularly rope in James to come in onto, I mean, this is it's not only our 50th episode, but it's also the last episode of 2023.
I guess so. I think you know better than me.
It's more that I was trying to remember the year.
Oh, the year. yes, no, it is. Yeah, the year is correct. Yeah, and apologies, people listening, you or me again, but here we are.
Don't sell yourself short. But what I thought would be quite a cool thing to do for our 50th episode, and also the episode that's going to end the year that was our 20th anniversary as well. So everything's been kicking off this year, was to talk about just how incredible sharks are as a group of animals and just how much they've survived over the years, over the many years that they've been on this planet, because they've been on this planet for, we think, some form of shark has been around for about 450
definitely
years?
in excess of 400 million years. There was some form of some ancestor of shark, which it's pretty nuts, because that's older than trees, dinosaurs, other fish, pretty much most terrestrial vertebrate life, which is pretty crazy.
Yeah, trees was 390.
390, so they've just pipped trees.
Just pipped trees.
But it's not plants, is it? There were other plants. It's trees are a specific type of plant.
I believe so. Yes. Anyone who is an expert in that field, feel free to write in if we're wrong on that. But yeah, trees were around 390 million years ago, but they definitely trumped the dinosaurs. So 240 million years was the dinosaurs. So
okay, yeah, a long way.
Sharks have been around over 200 million years longer than the dinosaurs.
That's pretty nuts.
And outlived the dinosaurs as well, which is my favorite fact about sharks.
Yes, yeah, dinosaurs were a blip in the history of shark kind.
Take that, Jurassic Park.
Yeah, that's pretty crazy, actually. Yeah.
Yeah, so there's the reason that the evidence that we have, or the earliest fossil evidence, was from 450 million years ago. And it was their denticles, it was their scales that they found from the acanthodians or spiny sharks.
Spiny is easy to remember than whatever you
I'm
just
quite impressed I managed to say that with jet lag as well.
But I mean, it's quite interesting there, because obviously, like, denticles are basically shark teeth on skin. So they're finding the denticles, but not the teeth from that period. Is that right? Or
I think so. So hang on. For listeners, we just took a pause there while I pulled up my notes for
we're cheating.
something exciting that is coming up on the World of Sharks website, which we will be. It's the World of Sharks website, isn't it?
It is the World of Sharks website. Yeah, we're gonna have a new feature
that we're going to talk about at the end of.
Okay, the end of the episode. We're not going to talk about it now. You're gonna have to wait in anticipation.
But yeah, so we've been working very hard on this, and I've just pulled up my notes to answer when the first shark-like teeth first appear in the fossil record. We have the oldest undisputed shark scales coming from 420 million years ago. Okay. I'm not even going to try and say the genus.
Something
sharky. And then the earliest shark-like teeth come from an ancient fish called Leonodus, and also another species called Doliodus problematicus.
Dolly what?
Doliodus problematicus.
Problematicus, okay.
Which is a great name for a species, but it's 410 million years ago. Apparently, it's the least shark-like shark. But the cool thing about this species is that in 2017, researchers identify it as the first evidence of a transitional species between the spiny sharks and the ancestors of the sharks that we know now. So they had some traits from the acanthodians. Sorry, listeners, for my pronunciation of these things.
They're going to be judging us.
Judging me hard. Emails are flooding in as we speak. But the spiny sharks / acanthodians, so they still had some traits from them, but they also had features that we would recognize as sharks today. So a shark-like head, skeleton, and the teeth, which is what we have in the fossil record.
Okay, so at this point, they're starting to get more than just the teeth and denticles. You're actually getting fossilized skeletons and things.
Yes, I believe so. So they're starting to look a bit more.
Well, I guess that's quite unusual because of the cartilage, as in are you less likely to get fossilized cartilage than with all the bony fish stuff? As in, bony fish actually have ossified bones as opposed to cartilage, and does that fossilize better? Isla's nodding, looking at me vacantly. We may have to cheat again, listeners.
I assume so. Well, this is the problem with sharks, right? Is that you don't have that in the fossil record. You don't have their bones in the fossil record. Pretty much all we have is teeth, parts of the skeleton that are pretty thick or calcified cartilage. And then also, what I didn't find out until fairly recently is that their dermal denticles appear in the fossil record as well. We're going to talk a bit more about that on a future episode in season 5, which I'm very excited about. Shark skin time machine.
Shark skin time machine.
Yes.
Less comfortable than a hot tub time machine.
Much less comfortable, I think. But even Doliodus problematicus didn't really look like a shark. We don't get the first sharky-like forms until 370 to 380 million years ago, which was when the Cladocelatches.
Don't look at me. I have no idea.
Anyway, a group of fish appeared. They have that very first distinctive kind of predatory shark form that we would recognize today. But some form of shark-like fish has been around since 450 million years ago, I think was the point we were trying to make.
Yes, which is, importantly, before trees.
Before trees, and well before the dinosaurs.
Well before dinos.
I also want to talk about, because not only have they survived all of that time, but they've also survived through 4 of the 5 mass extinctions. And I wanted to discuss them a little bit because I don't think we've really paid much attention to that on the podcast before.
Can wipe out all the dinosaurs, or at least everything that didn't turn into a bird. That's not exactly how it happened. That's a bit of a reduction of evolution. So, but yeah, it's pretty crazy that sharks sort of continued on merrily, at least some of them.
Yeah. Because they survived. So we've got the late Devonian, which was actually 3 extinction events that occurred between 375 to 365 million years ago. So around the time that those first predatory sharks first appeared. Some say it was a large-scale volcanic eruption, which caused the Earth to cool. And others say it was deoxygenation caused by the rapid expansion of plants.
Villainous trees.
Well, yeah, those trees. That's when the trees appeared.
Shocking. That's crazy. Well, so the cooling would have been because like all the ash and pyroclastics and everything blocked out sunlight, and then deoxygenation because no, that doesn't make sense. Surely the true plants would have created oxygen.
Well, no, but I think what also happened is at the same time, because of the expansion of plants, it caused rapid flushing of nutrients into the ocean. Well, that's one of the theories behind, or at least there was a paper that came out very recently, because for a long time there was a bit of confusion as to what happened. So we know around that time that the climate cooled, but we also know that there was deoxygenation in the ocean. And that is the reason why this mass extinction affected mainly marine life.
Okay, so they all just basically suffocated in the sea.
Yeah, which is really sad.
Wow.
I think it was like 60 to 70% of marine life,
Jeez.
Which makes it even more impressive that sharks are still around, right? But scientists for a long time have been really divided over what caused the deoxygenation. So it was either volcanic activity or it was the expansion of plants, of the trees. Yeah.
How do they do it? I mean, surely the trees themselves should be giving them more oxygen as opposed to causing it to. How did that happen? How do they?
Plants and trees cause this thing called chemical weathering. It's a process where they pull nutrients out of the soil. But when they died and decomposed, all of those nutrients suddenly ran into the ocean, and the ocean at that point hadn't had any nutrients of that kind. And so one of the theories is that it caused essentially a huge algal bloom.
Like a massive eutrophication event.
Exactly, which consumed most of the dissolved oxygen in the water.
Yeah, left none for all the creatures.
Yeah, which is sad. But that paper, which is by Filippelli and Gilhooly, which came out literally, I think, this week, the week that we're recording, said that there was a combination of the two. Yeah. So it likely was...
The interplay between...
Yeah, because at that time, obviously, everything was going crazy. Volcanoes were erupting left, right and centre. But then you also had trees for the first time and plants for the first time, which I think is really interesting to think about, because we think about plants as a really good thing, and they are in this age, but at that time they're an absolute menace apparently.
Yeah, I guess whenever you have something new that sort of changes the imbalance, it's all going to be shifting until it finds that new balance, until something else comes along and unbalances it again, causes another shift, like us. But
Exactly. Well, that's the thing about reading about a lot of these mass extinctions, is that a lot of it is echoing what is happening now, except the only difference is what's happening now. The late Devonian extinction was across 10 million years, whereas
yeah, this is much more acute.
yeah, we're speeding up the process quite significantly.
Sticking on fast forward.
Yeah. But then we have good news, because sharks survived. Some form of shark managed to avoid suffocating in the ocean, which is amazing. And then that leads us into what we call the golden age of sharks.
Golden age of sharks. You mean we're not in the golden age of sharks now, but they had cooler sharks back then? What gives these sharks the golden age title?
Well, I'm not sure we should actually call it the golden age of sharks. It should be the golden age of chimeras.
Because they're not sharks at all. They're imposters.
Imposters. Well, I mean, we didn't find out until relatively recently that a lot of these were actually chimeras rather than sharks. But I mean, they're cartilaginous fishes that have some really cool adaptations. This is when we see the buzzsaw shark, so the one with the...
Yes. Is that this might be one of the only fossil shark creatures I might know the name of, but is that the helicoprion?
Yes. But helicoprion or helicoprion, however you say it, was only a genus of the whale-toothed shark.
Oh, so there's a whole plenty.
There were loads of these
Amazing.
guys. Yeah, there was one, Adestus, which had teeth like scissors, basically. So its jaw was always open, and one of the jaws eventually, because the teeth didn't fall out, so the teeth would just move forwards until its teeth were all sticking out of the bottom of its mouth, we think.
So at some point it just couldn't use it anymore.
Yeah.
And so you're telling me these weren't sharks, they were chimeras?
Yeah, so the whale-toothed sharks, in quotation marks, were actually chimeras. There was also Falsettus, which had a spiny protrusion out the front of its head.
You're missing a great impression of basically a unicorn shark.
A unicorn shark, yeah. And then there's also Stephacanthus, who is the...
You're just showing off now.
It's only because I've been writing all these notes for our secret thing.
Yes.
It's called the anvil shark because its dorsal fin was shaped
like
an
I've seen
anvil.
that one.
So bizarre. We have no idea why these adaptations existed, but basically one of the theories as to why there was so much of this diversity all of a sudden is because that mass extinction event in the late Devonian caused a lot of the larger predators to die out. And so sharks and chimeras really had the opportunity to diversify. And now chimeras, we've only got like 50 species, right? Whereas at that time, it was like chimera central. But we also had sharks as well.
Okay, so the sharks as well as those chimeras. So what were the sharks like then?
In our sharks category, we have some pretty cool ones as well. We have Lystracanthus, which was a genus of sharks that were around in the Carboniferous period, the golden age of sharks, and they had feather-like dermal denticles. So the dermal denticles could be up to 4 inches in length, apparently, and they had a large main spine with lots of little secondary spines attached, a bit like a comb or a feather. They were described as fiercely bristled and eel-shaped. They're definitely a shark. The scientist in the paper that I was reading described it as somewhat unusual elasmobranch. Because we were joking around that dinosaurs were feathered. Yes. And they were like, oh, I bet you can't find us a feathered shark.
So we do. That's pretty cool.
There you go. Lystracanthus. We also had the Hybodontiforms, also known as the hump-toothed sharks.
Okay.
Which had a shark-like body, so looked quite similar to what we would have today.
The sharks look like sharks.
The sharks that look like sharks with uniquely shaped dorsal fins. So it had like a single spine in the front of it that maybe served a role in self-defense. But they were the first sharks in history to have different types of teeth for different purposes.
Okay. To have the knives and the forks.
The knives and the forks, yeah. So we had this really fun time where sharks were experimenting with what a shark could look like. And
then they sort of narrowed it down. When do sharks start to look like? Is it before the next mass extinction, or does it happen again after a mass extinction that we start to look like, I guess, do we call them modern sharks?
Modern sharks. That's a good question. I do have the answer to that. So the first modern type sharks are around 260 to about 240 million years.
So then where does that come in the mass extinction timeline? We have the late Devonian deoxygenation volcanic party there. Then what?
So it comes after the end Permian extinction, which was the big one.
The big one.
A lot of people focus on the one at the end of the Cretaceous period, which is actually the last mass extinction. And that was the one that killed the dinosaurs. So everyone talks about that one. That was the famous asteroid that everyone wants to talk about. Whereas we have an extinction at the end of the Permian period, which is around 250 million years ago, which is called the Great Dying.
Oh, wow. Well, that does make it sound like they were underperforming dyings. Like this one was pretty great.
Yeah, the other ones were just, just a couple of species, just 70% of marine life. But this one was 96% of ocean life and 70% of terrestrial life died out. And this is the scary one for me because it's quite reflective of what is happening now.
So it's not volcanoes or asteroids or aliens or... Just to clarify, none of them were aliens.
No, none of them were aliens, but it's global warming, basically. So the temperatures were rising, and that caused the oceans to lose around 80% of its oxygen. So,
which we're starting to see now.
Yeah, so it was similar to the late Devonian, which again was deoxygenation, but this time for a different reason. And apparently, even the deep sea wasn't safe. So half the seafloor was completely devoid of oxygen.
Yeah, it makes it hard to breathe.
Yeah, exactly. So it makes you think... It's pretty mental that if 4% of ocean life survived that, some of those were sharks. And so we made it through the Great Dying, and then we came to the end Triassic, which was 200 million years ago, so they only had 50 million years to recover from that. This one was pretty, I don't want to say not bad.
Okay, so it just qualifies as a mass extinction?
Yeah, it doesn't seem it was that awful. But we had continental drift that caused volcanic activity that introduced carbon dioxide into the atmosphere and caused global warming. And then we have the famous one, which was 65 million years ago. So that's the famous one that killed the dinosaurs. So the end Cretaceous, or the KT, which I'm fairly certain was an asteroid. I think that's the most popular.
I mean, at least that's what I remember from having been taught about it. That doesn't mean that someone now thinks something different, but I don't know. I could be completely misremembering here, but asteroids plus maybe even directly linked volcanic activity, which the combination also gave a whole bunch of ash and black stuff out. And...
Sure. I mean, it just wasn't very good for our dinosaur friends. But in the oceans, I think the most serious thing that happened in the oceans was maybe some loss of oxygen again, but also there was some suggestion that the sea level dropped. So we maybe lost some shallow areas. So thinking about sharks, maybe like nursery areas we're gone. And around this time, we're starting to see pretty much ancestors of the modern sharks that we have now. So quite a lot of them survived to become the sharks that we know today. But yeah, it's pretty insane when you think about it, how much they've got through.
It's pretty crazy. They've had most sort of acute natural disasters in some form thrown at them, and they're still just cruising around in our ocean depths, doing what sharks do, which is swim and eat mostly. Yeah. But yeah. Yeah, maybe that's why they're so successful, because they keep it simple.
Maybe that's the answer to life. I wanted to have like a bit of a conversation about what is it that has made sharks able to survive all of that time and all of those, terrible extinction events. But then, what makes them so successful as a group of animals?
Yeah, it's a good question. I think it's probably they all live in a pretty resource limited environment, or where the resources are at least very patchily distributed. So you're not quite sure when or if or how you're going to get your next sort of batch of energy from. So I think that a lot of what makes sharks so successful now and historically is they have sort of a whole suite of adaptations that basically make them really efficient. And so, they're able to get by with maybe not eating as much or as often, basically expending as little energy as they have to survive, which also then has all kinds of other implications of what you need. If you're spending less energy, you need less energy. So these are things like everything from things that make them hydrodynamic, or their buoyancy, or the way and how they eat. So stuff like, we've been talking a lot about their denticles. So for people that aren't quite sure what that is, that's the plates on their skin that are like scales, but are basically teeth. And the way these work, one of the obvious things is it's armor, it protects you, but actually it makes them incredibly hydrodynamic from the way the water flows over their skin and then is broken up in eddies and things. It makes them slip through the water much easily, which means you're spending a hell of a lot less energy to move through this viscous fluid and find your prey or whatever. But also, I mean, most teleos, bony fish, they have something called a swim bladder. Because obviously if you're in the water, most things sink, and you need to find a way to not sink without really spending energy. And most fish have a swim bladder, which is basically a balloon in their body that they adjust to sort of stay at the correct buoyancy for what they want to do. If you're familiar with diving, it's basically the same as your BCD. It's getting neutral buoyancy. Sharks don't have this, but a few adaptations help. So basically, if a shark stops swimming, it sinks. But it usually sinks really slowly, so they don't have to put much energy into staying buoyant. And this is partly their skeleton. Their cartilaginous skeleton makes them lighter than if it was all bony. They've also got massive livers. They put a lot of energy storage of lipids and fats into their liver, and then that is more buoyant than water. So if you have a big, fat liver, technical term, then basically that's helping you sink much more slowly. So then actually the way sharks stop sinking is by swimming. They work like a plane with the lift as they move forward. And if you're only just negatively buoyant because you're light and nice or floaty because of your fat liver, then again, you don't put much energy into not sinking. You don't put much energy into shifting through the water. And then actually you get really good at eating highly calorific food. A cool thing about sharks is like their jaws and their teeth. If you think about other marine predators, sharks are pretty much the only marine predators that can eat things that are bigger than them. You know, by being able to extend their jaws, by having these teeth that can cut through things, you can bite into highly calorific, you know, in modern day, whether it's seals or whales or whatever, dugongs, nice tuna or whatever, you can take a chunk out of something, which no other kind of fish can. So you're able to get these really highly calorific meals, might not need them very often, and you can sort of spend the rest of your time chilling and not requiring much energy. There are other adaptations as well, like their whole suite of senses. They've got things that if they were in a comic book, you would consider superpowers, like they can literally feel electricity. And, you know, they can even use, some species can even use that to navigate and everything, but they mainly use it to locate prey. And all of that comes back to the efficiency. How do you find prey more easily, spend less energy doing it? Yeah, these amazing senses that help you find the prey, whether it's through smelling, through olfaction, or it's usually a combination. You can smell things, that brings you closer. You then lose your electric to feel where it might be. And again, sort of all this comes together to just help them be incredibly efficient. And, you know, something that's also helped them is people would traditionally say they're cold-blooded, you know, in the sense that they don't regulate their body temperature to a certain range. But again, that can probably help, because if the ocean's cool and you're cool, your metabolic rate is lower. You don't need as much food to survive. You don't need as much energy, so you don't have to expend as much. Some of them, for transparency, do control the temperatures of at least parts of their body. But again, they're efficient in doing it. So like, I think, is it thresher sharks? They have these things called orbital reets, where there's a countercurrent flow of blood in their eyes that helps their eyes stay at least a bit warmer at cooler depths for longer, which keeps their vision working better at depth and things. So, or, you know, you have the mako sharks and the white sharks that can keep their core muscles warmer for the bursts of speed and things. So again, when they do, that comes at a cost. That's a higher metabolic cost. You've got to put energy into keeping things warm. So even when they do things that like that, it's only where it has to be.
It's called regional endothermy. It's the fancy
Probably.
scientific term for it, I think, because I just found out basking sharks have it.
Whereabouts?
I can't remember. Hello, Editing Isla here. That research on the regional endothermy of basking sharks was published earlier this year, 2023, by a group of scientists led by Hayley Dalton, and they showed that basking sharks are able to keep their core warm. So they found red muscle in the trunk of their body that helps to keep that part of their body warm in colder temperatures, which is pretty darn cool. And I will leave a link to that paper in the show notes if you're interested. Anyway, back to the episode.
So yeah, it's obviously they've stumbled upon evolutionarily these whole suite of adaptations and body plans that are just collectively a really successful suite of adaptations.
And it's allowed them to diversify, right? So
yeah,
they can fulfill lots of different niches.
Exactly. There are all kinds of sizes, there are all kinds of habitats, and from the surface waters down to in excess of 3,000 meters deep, there almost isn't a place in the ocean where there isn't a type of shark eating almost anything.
Yeah, because that would help in an instance where you had something that was affecting the surface waters. You would have sharks that were living in the deeper waters, and so they would survive. Or, for example, with the great dying, because so much of the seafloor was, pretty much there was no oxygen down there. And also at the higher latitudes, apparently. And you had some species that were at the higher latitudes that you require more oxygen when you're there because you're trying to stay warm. Whereas in the kind of warmer tropical waters, they're already adapted to that kind of warm, low oxygen environment. So the sharks that were around in the tropical waters could move away and find the same conditions elsewhere because the waters were warming at that time. The scientist that wrote that paper wrote it was either perish or flee, which is quite dark.
Wow.
But you were saying earlier, it reminds you a little bit of the epaulet.
The epaulet shark, which is, if you're listening and not familiar with the epaulet shark, it's this crazy little creature that most people also call like the walking shark, because it literally can use its pectoral fins to haul it over land or the reef. And there have sort of been sequences in natural history programs where at low tide on coral reefs, these sharks will pull themselves across the reef into like rock pools in the reef where prey gets trapped, and then it's just like a buffet for them. They can just creep in and eat whatever, can't run away. But in doing so, they get exposed to high temperatures and they can't really breathe while they're out there. So they get used to very low oxygen and they have to sort of be able to sustain that. And then sort of how they adapted to do that. And then if you have sharks like this and other sharks living in other kind of extreme environments and such diversity, if something does go wrong ecologically, whether it's caused by an asteroid or a volcano or people, there's hopefully some sort of body plan and strategy that amongst all that is going to survive, that you can then sort of repopulate from post great dying. Was it great dying?
Great dying.
Yeah. Wow. Maybe they just did it really well.
Yeah, possibly. But gosh, it still blows my mind that like 4% of ocean life survived. And some of that were sharks that just so happened to be in
the right place at the right time.
The right place at the right
maybe
time.
Completely oblivious to the rest of Sound like a Greenland shark just bumbling along with parasites in its eyes. And
Greenland sharks would definitely be gone. So it was all the species
so
at the higher latitudes and deeper waters. Would Greenland, I mean, maybe some sort of ancestor, but Greenland sharks wouldn't have been around at that time, hey? Yeah. Well, maybe they've been around for, they're so old, potentially.
I think it's pretty crazy that, well, at least at the moment, there are individual green sharks. So based on evidence, there are probably individual green sharks alive today that like existed before America was a country, which is insane.
Yeah, or even when Shakespeare was alive.
Yeah. That's pretty crazy.
I'd love to speak to one of them and see what they thought. Well, yeah, the ocean's got a bit warmer, but other than that, it's pretty much the same.
Yeah, but they all speak different now.
And again, also we have the diversity of sharks. I mean, some of them were a generalist species, which means that they fed on lots of different things. So if their food source was taken out, they could easily switch to something else. It would have been the ones that were specialists and you could apply the same thing today. So the ones that can only live in a certain place, can only feed on a certain thing. And what springs to mind at the moment is, because why we're in Seattle is for the board meeting of the Shark Conservation Fund, and we've just had a guy talking about is it Morgian or Mogian?
Well, even amongst themselves, that's up for debate.
There's a debate, but there's this little skate. I mean, I don't actually know if it's little or not, but there's a species of skate that just exists.
I think it's around a meter or something. The adults will...
Okay, it's quite big.
I don't know, they had a graph today of like sexual maturity, and I think the top end of the graph was about a meter or something.
Anyhow, this skate there's only 500 individuals left in the wild, and they all exist in this kind of very specific lake, is it? Or
well, no, it's like a lake, but it's part of the ocean. It's a natural harbour in Tasmania, which just has a very narrow in terms of shallow entrance, but then the natural harbour is very deep, so it creates this sort of weird conditions which the skate lives in.
Very, very, very specific.
So that skate's highly specialized and would be, I mean, even without a mass extinction, it's well, you could argue we are currently in mass extinction, but it's in trouble. Whereas maybe something like a tiger shark, which you can find all over the place and will eat pretty much anything, might fare a little better.
So sharks are pretty resilient, I think it's fair to say, and incredibly well-adapted animals and well-adapted to change. Because I think when we had Jodie Rummer and Carolyn Wheeler on to talk about climate change, we were discussing the fact that there is a possibility that some might survive. But even the epaulet shark, so the epaulet shark is the one that they're working on, even the epaulet shark at the temperatures that we're seeing the sea get to, that's even affecting the epaulet shark, which is like it's kind of like the canary in the mine, I guess, because if they can't deal with it, then it's not looking good for a lot of other species. Anyway, I wanted this episode to be on a more positive note.
With such variation, they will find a way.
Yes, but also just to emphasize the fact that these animals have been on this planet for 450 million years, which is an incredible feat. And they've survived so much. They've had so much thrown at them, from volcanoes erupting to asteroids hitting the Earth to the ocean losing 80% of its oxygen.
Yeah, it's astonishing. It highlights just how amazing they are and really why we love them so much, because they're absolutely incredible. And they have been busy being incredible for, in excess of 400 million years.
And that's why we love them. And that's why we have this podcast.
Only now they're like, finally, someone appreciates us for how awesome we are. We've been busy in the oceans doing all this stuff. And only now we're getting our own podcast.
Yeah, but they're more resilient than we think. And also, this is something we can do something about. So we can't do anything about an asteroid. We can't do anything about a volcano, but we can do something about the problems facing sharks now.
I'm pretty sure someone like Bruce Willis would say different about doing something about an asteroid.
Probably. What's that film? Is it
Armageddon or something? There was that film where they go up and blow up the asteroid to stop it hitting Earth. Was it Armageddon?
I don't know. I've not seen that film, but probably.
No.
So Bruce Willis, if you're listening, saving sharks will be easy for you if you've already saved humanity. Imagine if Bruce Willis actually listened. He emailed in and was like,
hey.
Bruce Willis here.
I can do that.
I wonder what his favourite shark would be.
Bull shark. Bull shark seems pretty action hero-y.
What's the really famous series of films that they usually play around Christmas?
Around Christmas. Oh, you mean Die Hard?
Die Hard.
Yes. Yeah. Yippee-ki-yay.
Maybe Die Hard. How many films are they on now? Die Hard.
I think there was at least 3. There may have been much later of 4. I don't know. Someone is listening, thinking, cursing us for not knowing exactly how many Die Hard films.
Sorry.
Yeah.
Die Hard 5, Save the Sharks. There we go. We need to make that happen.
In which the sharks do not die hard.
Survive hard. Oh, God. Right, the jet lag has hit me really bad now. We've kind of talked about how successful sharks are, which was the main point of the podcast, but I also wanted to talk about 2 other things while I've got you. One of which is we had a question sent in by a listener called Matty, who writes in a lot and is a big fan of the podcast and is always very lovely when she talks about the podcast. So thank you so much for writing in, Matty. And they say, what can I, as a year 8 student, so I'm guessing in the UK, that's around 11 to 12. Yeah. But I'm not sure, Matty, if you're in the UK, so if you're older or younger than that, I apologise. But anyway, they say, what can I do as a year 8 student to help get my friends into the world of sharks and conservation? So I'm guessing Matty themselves are very into sharks, obviously, but they're wondering how they can get their friends into sharks as well.
Well, yeah, it's often tricky, and the big challenge is getting enough people excited and passionate and caring about it to sort of want to make the changes in their lifestyle that people need to help save sharks. I think simply one of the most important things people can do is talk about it. Think about, why do you love sharks so much? Because you found out about them from someone else. Yeah, and often the big motivator for fascination isn't about how big the problems are. In fact, that can be quite intimidating and sort of put people off it, but try and inspire about how awesome and cool and amazing they are. And it's a challenge that we also experience. It's like, how do we get people interested and engaged enough and excited about sharks to care? And it's just finding different ways to look at things or communicate about it. And maybe this is something that your peers would be interested in, but we've in some ways started talking about sharks like superheroes, and we have our whole sort of super shark campaign. And the whole idea about that isn't like trying to give sharks imaginary superpowers. It's realizing that many, in fact, some of these adaptations we've already talked about are like real natural superpowers. Basically, some of these sharks are like magneto sharks for real.
Can you elaborate on that?
Okay, fine. They can't. They can't control metal through like telekinesis. They're not literally magneto sharks, and they don't speak like Ian McKellen. But
that's from X-Men for anyone who isn't familiar with that film.
No, so this is sort of looking back at their electroreception, but they can literally feel electrical fields. And the way this is cool is they can feel your heartbeat. And so if you are hiding under the sand as prey, terrified, you might get chomped by a shark. Even if the shark or ray can't see you, they can feel your presence. So maybe it's a bit more like Yoda. They're not magneto sharks, they're Jedi. And there's recent evidence that shows, from some sharks at least, that they can also feel the Earth's electromagnetic field in a way that they recognize position, so that they can use that to know exactly where they are and navigate. Like, people have been able to show sharks are fantastic navigators before, but not quite sure how. And one of the ways looks like that's possible is through electromagnetism, hence the magneto shark aspect. So if you can talk about sharks having these amazing adaptations, and some of them glow in a way that only other sharks of the same species can see, is that because they're living in such places. So this is like the swell shark, they in rocky habitats where they're camouflaged and stuff, but you still need to find your mates. And if your mates stick out like a sore thumb, because as far as you're concerned, they're glowing green. I mean, they may not see them as glowing green, but there's all these kind of things that are really cool and interesting and different about sharks that you don't really get in other animals. So yeah, sorry, again, I've ended up rambling, but it maybe.
But I think that's great, though. I think people respond when you're passionate about something. People respond to that, and it's infectious if you get someone who's like passionate about something like that.
Yeah, so I think a lot of it is inspiring just how amazing and awesome these animals are,
and also that there's more to sharks than the Jaws trope, yes. Right? So I think it's quite hard for people who maybe aren't into marine life or have that fear around sharks to get on board with something like a great white. But you can talk about how diverse they are, and there are some quite what we would call cute species. So one that springs to mind for me is the shy sharks, which are these amazing, beautiful little sharks that kill into a donut when they're threatened. Like, they literally put their tail over their eyes. And I would challenge anybody to not find that adorable and immediately want to know more about them. But also, I acknowledge the fact that sharks are amazing, and we obviously all share that thought pattern. But for a lot of people, it's difficult to kind of come round to that line of thinking. I mean, they are a fish, but something else, another kind of route that you can take if you're finding that people just aren't they're like, oh, right, okay, cool, sharks can sense electricity, blah, 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 but it's still a shark, I'm still afraid of it. You can talk about how important sharks are to other marine animals that they might care about, and how much of an integral role that they play in the ecosystem. So if you take sharks out of an ecosystem, for example, that might cause that ecosystem to collapse, and that will affect numerous other species that they might care
exactly
about.
Like whether you like turtles or dolphins. I mean, there's quite a good example in Western Australia where they have a lot of good data that exemplifies a scenario where sharks play exactly that kind of role. So you have tiger sharks in big seagrass ecosystems in Australia, and so there's now enough data to show that the presence of tiger sharks is critical to the presence of that seagrass habitat. Basically, the sharks swim around trying to eat the dugongs, the turtles, the dolphins, the sea snakes that all live in this habitat. But as the sharks swim around trying to find and eat these things, even if the sharks don't eat a particular prey type that often, there's this massive role of fear. It's called the landscape of fear, where the prey species massively modify their behavior depending on the presence of sharks. You have this scenario where essentially through the risk imposed by the presence of these sharks, the seagrass habitats get protected because they don't get overgrazed. And then in places where you have lost this presence of sharks, there's no longer that fear imposed. So the animals that were already there are happy to go around and graze as much as they like. Seagrass gets overgrazed, and then once it's overgrazed, algae establishes in its place, and then the seagrass can't reestablish. And so, that whole sort of ecosystem collapses.
If people aren't fans of sharks, they're likely going to be able to get behind some of the species that live in those habitats. So I guess for me, just another thing is probably just the sheer injustice of it. Like, I still don't think today a lot of people realize just how much of an impact we are having on sharks. I mean, hundreds of millions are killed each year by humans, and I think that figure alone is it's just so confronting to think about. And the fact that we've seen a 71% decline in the abundance of oceanic shark species. I mean, we can always say that human-induced climate change and human problems. There probably is, but sharks are one of the most stark examples of our impact on the planet, I think. And it doesn't matter whether you're scared of them or not. Like, that fact alone is quite confronting, I think. And also, this is one of the things that we can do something about, So
their most acute problem is overfishing, and overfishing is something we have direct control over as a people generally, not us. Yeah, so the solution is relatively clear. It's fish them at a rate that they can still reproduce and sustain themselves.
But anyway, I guess that was quite a long answer to your question, Matty, but I do appreciate it's difficult when you're trying to kind of get your friends into something that you're interested in. But I think I would just try little tidbits at a time. So, try and explain to them like some of the shark superpowers, or, be like, oh, just get a shark image on Google and be like, have you seen this? Like this really cool, funky thing. And then kind of try and introduce that conversation from there.
Or cool little videos like, did you know there's a shark that can walk on land? What? No,
Yeah, or get them to listen to this podcast.
Yes.
Get them to tune into World of Sharks.
Definitely. Or go to the World of Sharks website or any other similar site that shares cool, interesting shark content that is there specifically.
There's also some fantastic creators online who, talk about a lot of this stuff. Because I know I'm going to sound really old here. I know we're in like the social media age, and there's a lot of TikTok videos about sharks. So yes. Jada Elcock, Fishtication, springs to mind. Armani Weber-Schultz, Kaylee Biologist, she does a lot of videos about sharks. And then on YouTube, there's Shark Bites.
Yeah, there's a lot of great short format shark content that could be, nice and easy digestible and is interesting more generally as well. So you don't have to be a shark geek to get something out of it, and then hopefully in the process of enjoying it, you become a shark geek.
Yeah, join the shark nerd community. It's very fun over here. Anyway, thank you so much for writing in with your question, Matty, and it's also always nice to hear from you as well. So thank you for all the emails. We really appreciate it. And then I suppose last thing that I wanted to pick your brains on is because this is the last podcast of the year, and we've had a very busy year for the Save Our Seas Foundation.
Slightly understatement. Yeah, it was our 20th anniversary this year, but we've had a whole bunch of different sort of events and locations across the course of the year, which have all been really fantastic. It's been really nice engaging with sort of the local ocean community in each place, and we've had local speakers and showing films, and with the whole sort of theme of just celebrating our seas and getting people together to sort of share their love of sharks.
And then what else is in store for us next year?
Well, I think you may have alluded to something earlier. Oh, something to do with, what was it? Extinctions and stuff. Isla herself has been working along with other members of our team, especially Jamie in particular, but also Jade and others, on basically a scrolling timeline on the history of sharks. And the whole idea is to get a sense of the diversity and scale and magnitude of the amount of time they've spent on this earth. And although I'm hugely excited by this, it'll be on the World of Sharks website, but I've mostly been involved in a peripheral sense. Maybe Isla, you could tell us a little bit more about what we can expect to see in our scrolling timeline of a history of sharks.
Oh, goodness me. I don't know how much I can reveal, but I do know that. So Jamie is our graphic designer or illustrator who is amazingly talented. And she has done some incredible work illustrating some of these weird and wonderful species, some of which we alluded to at the beginning of the podcast. So it'll start right at the beginning of time, I believe, and then kind of quickly get to where sharks first appeared in the timeline. And then you can scroll down the page and you'll be able to see, the mass extinction events come up, but you'll also be able to see what sharks were around when. And then what we've done as well is, or what Jamie's done, I should say, I've helped out with a lot of the kind of digging into the literature and looking at the science side of it. But what Jamie has also done is lined it up with what animals were around at that time, what did the terrestrial environment look like, what did the marine environment look like, so you kind of get a real sense of what life was like then. And it goes through right from, we decided not to kind of go too far into the very beginnings of life. Yes, yeah. But we definitely go into a lot of detail about the sharks or the chondrichthyans as a whole. And if you think about it, that's 450 million years that we've covered. So it's been quite a fair bit of work.
That's pretty crazy. And then it includes other notable things. Yes. Like where the first
this is when
trees,
the first trees, when the first whales appeared, where the dinosaurs were. I don't hate the dinosaurs. I just think they get way too much attention. Just everything. We've kind of covered a lot of bases. But yeah, so the scrolling timeline is a big body of work, and a lot of that work goes down to Jamie and Jade and the team.
Yeah, it'll be a lot of. Hopefully, it'll be all nice and seamless and lovely. Well, I know it will be, but there's a lot of hard graft behind the scenes that's gone into creating that.
Sure, yeah, because not to go into too much detail, but a lot of it is you fall down rabbit holes really quickly. Because in the world of paleobiology, nothing is certain because all we're going off is some teeth. Yes. Most of the time, and how you guess what a shark looked like just from its teeth is quite tricky. And there's a lot of debates about when they appeared in the fossil record or when these species were around. There's a lot of debates about what they look like. People are still arguing about what Megalodon looked like and how big Megalodon was, and that's the most famous shark, so it's interesting. It's fun. It's really fun.
I'm very excited for us to be able to share it, because I've sort of seen the assets and stuff separately, and then when it all comes together, I think it's going to be really quite impressive. But yeah, so that's one of the sort of main things we're hoping to launch relatively early next year. There are going to be other things as well. We mentioned super sharks earlier. We're releasing an update on our previous super sharks. It's basically expanding the deck, as it were, and including some of the cool creatures that we didn't have in the previous set of cards. So our super shark cards are like a trump card game, where the different characters are the different super sharks with their natural adaptations. Actually, so I found a way to include the velvet belly lantern shark in this episode. The new deck is going to have the velvet belly lantern shark in as one of the super sharks, which makes my day, because they are the coolest shark.
Which is a shark that has
lightsabers and an invisibility cloak. Yeah. But if you have listened to other episodes, you'll know. I think
we have mentioned velvet belly.
Yeah. Okay.
On the Weird Sharks episode, because yes. I rep the velvet belly for the.
Excellent. Yes, you did, and I'm sure I've probably bored people with it before.
You can't. Can you actually bore people with the velvet belly lantern shark? I think.
Well, I don't.
That would be quite a challenge. Yeah. So really cool stuff coming up on Save Our Seas in general, and then also this podcast will be continuing. We'll continue well past our 50th episode into the future. We're also, the core of what we do is our grant-making schemes. We're opening both our small grants, which is specifically for early career researchers, and our keystones, which are bigger, longer-term grants for applications next year, probably sometime in
April or so, May maybe. Keep an eye on that if you're interested for details. Later in the year, there will probably be some form of storytelling grant. So if you're interested in the communication side of things, we've done both photography and writing versions of these in the past, and sort of watch this space for what will come next in that sort of series of grants. And otherwise, I think the team will be taking a very well-deserved sort of deep breath and sort of return to some form of normality post a year of 20th anniversary celebrations, which I think will be much needed and appreciated. But then sort of as I say that, I'm also thinking about...
We'll see how long that lasts for.
I'm also thinking about, okay, now we're not doing this. There's all these conferences we can go to, and we can do that. And then we're already thinking, well, what events can we hold alongside? And then it's just going to be the same again. But it's what we do and we love it. So
games. Yeah. Well, thank you very much, James.
Not at all.
Coming back on the podcast, and
thanks for putting up with me again.
You're welcome. No, thank you very much for coming back on the podcast and having this chat with me about how successful and how awesome sharks are.
They've done okay so far.
I think that's fair to say. They're doing all right. But yeah, thank you, James.
No worries. Thank you for having me.
We'll see you again at the end of season 5, probably. And that is a wrap on season 5 of the World of Sharks podcast. As always, we will be taking a break over the festive period, but we will be back in February next year with even more episodes packed full of sharky science, facts and stories to keep you entertained, and even more incredible guests. So stay tuned for that. We'll release information about that on our social media, so keep your eyes peeled. And just as a reminder, this podcast was brought to you by the Save Our Seas Foundation. It was hosted and produced by me, Isla Hodgson. Our amazing visuals are by Jamie Silver. Our beautiful logo was made for us by Nicola Poulos, and the wonderful jingle you can hear right now is by David Knight. Again, thank you all so much at home for listening to this podcast. If you like this episode and you haven't done so already, please be sure to rate, review and subscribe on your podcast apps. It really means a lot to us. It helps more people to find us and more people to find out about how amazing sharks are, and who doesn't want that. If you would like to get in touch, if you have a question or a topic that you want us to cover next year on the podcast, or a guest that you want on, or you just want to say hi, please feel free to get in touch. You can do so by emailing isla@saveourseas.com or by contacting us on social media. We are at Save Our Seas Foundation on Instagram and at Save Our Seas on Twitter. Alrighty, have a awesome festive season. We wish you all the best for 2024, and we will see you in the new year.